Good morning, students. Today we'll start the second lecture of motion in plane, which is related to general vector and rotation. Students, already we have studied the physical quantities which is related to scalar vector, and also in previous class studied the representation of vectors, position vectors, and different type of numericals. Now here see, today we will start with some definition. Equal vector. If the magnitude and direction of two vectors are same, then these are called the equal vector. Here you see vector A and B. These are the same in magnitude and direction are same. So these are the equal vector. And similarly, the negative vector. Negative vector, here you see the vector AB is in the direction and vector BA is in opposite direction. Both are in the same magnitude. So if the magnitude of two vectors are same but they are in opposite direction, then they are called negative vectors or opposite vectors. Fixed vector. If the initial point of vector same, we know that the in vector notation, what we see that these are the initial point. If these two initial points are same, then these vectors are called fixed vector. And if the initial points are not fixed, then this is called free vector. Coplanar. You know that the xy is the xy plane. xy plane. If a set of vectors, here you see 1 vector, 2 vector, 3 vector, all are in the same geometric plane. All are in the same geometric plane. Then these vectors are called coplanar vector. Co-initial vector. If the initial point of two or more vectors are same, then it is called co-initial vector. Co-terminus vector. If you see here, the vectors are terminated at a common point. Okay. So a vector is share the same terminal point or end point. Then these set of vectors are called the co-terminus vector. And another important is that zero vector or null vector. You see, this is the zero. Magnitude of is vector is 0, and it is in arbitrary direction. It has no definite direction. It is an arbitrary, but direction is there. Here you see two men of equal force. We know that force vector quantity. So if it is equal, so what will that in opposite direction? So resultant will be 0. Okay. So here you see in which direction this vector will come. This is the force. So there is no specific direction. Is the zero vector and null vector. What is the physical significance? Here you see, first one is the state of equilibrium. It represents a system where all force or torque cancel each other. You see, all force and torque in previous figure cancel out, and the net force of the vectors of an object is 0. Net force is 0. Okay. Then this is the translational equilibrium. It is not accelerating, and it is a state of equilibrium. It is not actually accelerating. So it is a state of equilibrium. Another is the origin. If the position is not changed, that means it is exactly the defined origin. Okay. If both are same, the position will not change. Okay. Lack of motion. Here you see velocity is vector. If velocity vector is 0, that means acceleration, there is no acceleration. So it is in rest. Velocity vector is 0, then it is rest. Okay. Either it moves the constant speed in a straight line, 0. Okay. Unit vector. Unit, you see, the terms is the unit. So it is nothing but 1 unit. So magnitude is 1. Okay. And it is denoted by this symbol, cap. A cap. This is the cap. Cap or hat. Okay. And what is the value? A cap equal to vector A divided by magnitude of that vector. Okay. Now we're going to one example. a boat is moving in the direction of this one, where I cap and j cap is the unit vector, with speed of 10 meter per second. Find the unit vector and velocity. Here you see, if vector unit vector is this one, so vector A equal to unit vector multiplied by the magnitude of the vector. Now here we first find the unit vector. The vector is this one. So what is the unit vector? Unit vector equal to vector divided by magnitude of this. Magnitude of this means square of this and this whole square root. So minus 4i plus 3j divided by root over of minus 4 square plus 3 square, and that equal to 25. So square root of this equal to 5, and ultimately the result will be this one. Next we move to the scalar multiplication of vector. Scalar multiplication is nothing but, you see, it is operation involved on multiplying a vector by a scalar quantity, any real number. Okay, suppose v is a vector, we want to multiply a scalar factor k. That is nothing but the product is the k vector v. Now that means the vector, the v will be increased by k times. If it is negative, direction will be changed, otherwise it is same direction. Okay, here you see vector v 3v, that is the magnitude will be increased by 3 but direction is same. If it is minus 2v, magnitude will be increased by 2 but it is minus 2, so it will be opposite direction. And half v, so it is the magnitude will be half, that means this vector will be half but it will kept in the same direction. Okay, thank you.